interviewing the sisters of Alpha Omicron Pi. So, Laura, what do you know about forces?
An object in motion stays in motion.
Thanks, cool. Now we're here with Paige. Paige, what do you know about forces?
Kinetic energy.
Thank you! Okay, now we're here with Maggie. Maggie, what do you know about forces?
Potential energy.
Thank you! Now we have Emma. Emma, what do you know about forces?
There's a normal force acting on an object and gravitational force acting on an object.
Good job! And now we're here with Depasha. Depasha, what do you know about forces?
I know about Air Force One.
And now we have Avery. Avery, what do you know about forces?
They go against each other.
Thank you! And now we're interviewing Taylor. Taylor, what do you know about forces?
That they're a part of physics.
Woo! And finally, we're here with Sophia. Sophia, what do you know about forces?
I know that they pull objects together.
Thank you! The thing that I found most interesting in this unit was falling objects and gravitational forces. It is common knowledge that with gravity, objects speed up as they fall. But what is happening to the objects as it falls? And as an object falls, there are forces acting on it speeding up. For example, if I drop this pen, there are forces bringing it towards the floor. We also focused a lot on Newton's second law of motion, which describes how the rate of change of speed of an object depends on both the net force acting on it and the mass of the object. The equation for Newton's second law is strength of force divided by the mass of the object is the rate of change in speed. The thing that interested me most is that objects of different masses actually will reach the ground at the same time. This is because the forces acting on them have different strengths. We learned that in the absence of air resistance, regardless of mass, the objects fall at the same speed. According to this pen and this hairbrush should both hit the floor at the same time. So let's test this out. So, as you can see, they both hit at the same time.
These concepts about forces are fascinating because they challenge our understanding of how objects behave under gravity. It's one thing to know that objects fall towards the ground due to gravity, but it's another to understand the other force behind it, especially when considering factors like mass and acceleration. Newton's second law provides a clear mathematical framework for understanding how forces and masses interact to determine the acceleration of an object. Realizing that acceleration due to gravity is constant for all objects near the Earth's surface, regardless of their mass, is a crazy realization. It represents the physical laws and shows that in their absence of other forces like air resistance, all objects experiment the same acceleration towards Earth. Sam's demonstration with the pencil and hairbrush confirms and solidifies that these concepts are true by providing a visual confirmation of what the theory predicts.
With the ideas about how motion of an object is determined by the forces acting on it, one of the forces we learned in class was frictional force that oppose the motions of an object when it slides across the surface. So when I push this sofa across the floor, I would be pushing with a force strength stronger than that of a friction force opposing the sofa being moved. So with me pushing this couch, I am the force exerted with my pushing, and then the couch is frictional force from the floor.
Okay, so today we're interviewing the sisters of Alpha
with the ideas about
Okay, now we have what's it called?
Force exerting